Okay, so we're looking at rotations. Rotations are a little strange and they're kind of hard to picture sometimes, especially when we're only looking at a point. But a couple things to keep in mind here is that, remember from Pearson that a counterclockwise rotation is considered a positive rotation. So if it says rotation of 90 degrees counterclockwise, that means we're moving this way, right? This is counterclockwise. Let me use my highlighter here. So this is positive, rotating this way. And strangely, although it looks weird, this would be negative. And when you get to trigonometry in high school, it'll make sense to you why this is considered positive. Also remember that when we look at our quadrants, we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And a key thing to keep in mind as you look at reflections, or rotations rather, is that when you're moving by 90 degrees, the point is going to shift one quadrant. So if I'm moving 90 degrees like I am here, it's going to go from being in this quadrant to being in this quadrant. If it were 180 degrees, it'd go from this quadrant to this quadrant. 270 would take it here. Or you could also think of 270 as negative 90 this way, which sometimes is easier to think of. And the other thing to remember is that when you are, for every 90-degree turn, the x and y coordinates are going to switch. So for example, with this point here, which is at 9, -4, the coordinates are going to be 4 and 9, and then you use what quadrant the point is in to determine whether it's positive or negative. So here we've got 9 and 4 are the numbers. Obviously 4 is negative here. But if I do a rotation around the origin, I'm actually going to go to 4, 9. But since I'm in the first quadrant, neither of those will be negative. Now it gets a little weird when you do 180, because what 180 does is 180 goes through 2 quadrants. And so the ordered pairs switch and then switch again. And so I'm going to go from here clockwise up to here. And that means that, again, the points switch back, so it's back to the same points, but it's not -5 now, it's +5 because I'm above the x-axis. So I've got point N here, and they're saying it's moving counterclockwise around the origin. That means it's going this way. So the points are the same, 6 and 6, but if I'm down in the third quadrant, they have to both be negative because x and y are both negative in the third quadrant. So the point 0, 7 is going to move clockwise, which means in this direction, down this way. And so instead of being at 0, 7, we're going to be at 7, 0. And then we've got this point 4, 10 clockwise around the origin, which means we're going to move into this quadrant over here. And so instead of being 4, 10, it's going to be 10, 4. But the 4 has to be negative because after all, we're in the fourth quadrant here, in which the y coordinate must be negative. This point is rotating 180 degrees counterclockwise. So it's going from here over to here. This point -3, 1 is going clockwise, which is this way. But it's going to move 180 degrees, which means it's going to move to the next quadrant and then one more quadrant after that. So even though normally for every 90 these interchange, it's going to stay the same. So it's not going to be 1, 3, it'll be back to 3, 1 again. But down here, 3, 1 looks like +3, -1, because the x coordinate will still be positive. It's the y coordinate that'll then become negative. Okay, this one's weird. It says 270 degrees counterclockwise. That means we're going to move from this quadrant to here, and then here, and then here. The other way to think about this is it's the same as moving 90 degrees clockwise. So it'd be like moving from here over to here. So instead of 5, 0, we'll be at 0, negative 5. Remember that for every 90, they interchange. So instead of 5, 0, it's 0, 5. But obviously, this isn't positive 5. It's negative 5. All right. So even though I've only asked you to get to a smart score of 80, if you're really ready for a challenge, you could look at doing a rotation of an actual shape, in this case, a polygon that has 4 sides, a quadrilateral. They're asking us to move this kite. Yeah, that is a kite. TUVW, 270 degrees counterclockwise, which is this way. We could also think about that as moving it 90 degrees in the clockwise direction. So that means that we're going to take each ordered pair and switch the coordinates. So instead of negative 3, 10, we'll have 10, 3, both of which have to be positive because we're in the first quadrant. Instead of negative 2, I hope it doesn't make me do this in order. Instead of negative 2, 6, we'll have 2, 6. Or sorry, 6, 2. Instead of negative 3, 2, we'll have 2, 3. 2, 3. And then instead of having point negative 7, 6, we'll have 6, 7.